covering section 13.8, and that is reciprocal trig functions. We're going to evaluate them and graph them. Okay, so first off, we have cosecant, secant, and cotangent, and we talked about those in our packets that we did, so I think most of y'all are familiar with them already, but we will review. Remember that the cosecant, and they're reciprocals of sine, cosine, and tangent. And what I told you between the sine and the cosine is it doesn't start with the same letter. So the cosecant starts with a C, so its reciprocal is going to start with an S, and that means it will be 1 over the sine. Secant starts with an S, so its reciprocal starts with a C, and it will be the cosine. So 1 over the sine is the cosecant, 1 over the cosine is the secant. Most people don't have any trouble remembering that 1 over the tangent is equal to the cotangent. Okay, so what I like to do on my unit circle, I take it back to where we were before, and this one for some reason doesn't have our tangent values on it that we put it before. So we had 0, we had negative square root of 3 over 3, we had negative 1, and we had the square root of 3. So this, excuse me, negative square root of 3. This is positive square root of 3, positive 1, and the negative square root of 3 over 3. And this is, of course, that one unit circle that's missing the negative sign right there. So, oh, and the last one, of course, is, forgetting this one, tangent is y over x, so negative 1 over 0 means the tangent value here is undefined. So, I'm putting this on here because when you have to calculate the reciprocal functions, then we're going to be taking the reciprocal of the x values. And for the most part, the x values that we have are on our circles, square root of 3 over 2, square root of 2 over 2, 1 half, 0, and then of course 1 and negative 1. So what I do is go put these in a chart because I don't want to have to calculate them every time I'm trying to do a secant or cosecant or cotangent problem. So I'm going to write those values as we just said. The numbers that you see, we have the square root of 3 over 2, the square root of 2 over 2, 1 half, and then we will see numbers, the other numbers we'll see on here will be 0. We will also see undefined, and then we have 1 and negative 1. So I'm going to go find out what the reciprocal of each of those. Well, the reciprocal of 1, everybody knows, is 1. And 1 over negative 1 is still negative 1. And 1 over 1 half, y'all are good knowing that's 2. Now, these two, it's technically not the reciprocal, but the point of it is if I take 1 over this number, 1 over 0 is going to give me undefined. And 1 over undefined isn't really equal to 0, but what's happening is if I do y over x, then I get undefined. But if I do x over y, then I'm going to get 0. So you need to know that these two are what we call the reciprocals for the purpose of our reciprocal trig functions. Okay? Then we've done this one a lot because we've also talked about when we found the tangent values, it was y over x. So this is the square root of 3 over 1, which is the square root of 3, or 1 over the square root of 3, and when we rationalized it became this. So we know that these two are reciprocals, which means the square root of 2 over 2, its reciprocal is going to be just the square root of 2. So the only one that we really have left, if we haven't learned it yet, is this one. And that is, so if I take the reciprocal of a fraction, then I'm going to flip it, and I can't leave that radical in the bottom, so I rationalize it. And that, of course, is where I'm going to get the number that I'm going to put into here, which is 2 square roots of 3 over 3. And again, I put this on my, I write it on my unit circle, and or right when I get my test, I write those numbers down because then when I have to go calculate, okay, so if she gives me a problem to do, and she's asking me to, let's go calculate what the secant of 315 degrees is. Okay, you're going to go to 315. Secant is 1 over the cosine. That's this number, and 1 over that number, I'm going to already have it written down, so I don't have to go and do some calculations of simplifying radicals or anything of that sort. So if I ask you for the cosecant of 7 pi over 6, you're going to go find 7 pi over 6, which is right here. Cosecant is 1 over the sine. My sine is negative 1/2, so the reciprocal of that is going to be negative 2. Because the number is going to change, the sign's not going to. The negative doesn't, it carries with it, as we saw right here. Okay? And one last one, let's say I asked you for the cotangent of 3 pi over 2. So if I'm looking for the cotangent of 3 pi over 2, then I'm going to go find 3 pi over 2, which is right here. And this is the tangent value. So if that's my tangent value, what's the reciprocal? Or, in quotes, then the reciprocal is going to be 0 because tangent was y over x. So cotangent is x over y and 0 over negative 1. Or if I have undefined, I know the reciprocal value that I need is 0. Okay, so back to our notes. We have some more. Cosecant of pi over 3. So if I want the cosecant of pi over 3, I'm going to think about where that is on my unit circle, and that is at pi over 3, which is in the first quadrant, and the coordinates of that point are 1/2 comma square root of 3 over 2. Okay, so cosecant is 1 over the sine, and the sine, of course, is your y value, so 1 over that number. That's what we just did on that chart. I don't want to have to do it every time. If you want to, you can. I think I'm probably a little bit lazy in that area. All right, cotangent of negative 5 pi over 4. This, again, causes some challenges for people, so I'm going to go back to the unit circle so you can see it, okay? And I'm looking for negative 5 pi over 4. So positive 5 pi over 4 is halfway around the circle and then to that purple tick mark. That's 5 pi over 4. So negative 5 pi over 4 is halfway around the circle up to that first purple tick mark. So this is where negative 5 pi over 4 is. You can also go find the positive and then flip it over your x-axis, and that will be where the negative 1 is. So if we go back to my problem. All right, so negative 5 pi over 4 we just decided was in the second quadrant, and the coordinates of pi over 4 in that quadrant are negative square root of 2 over 2, comma, square root of 2 over 2. And it's asking us for the cotangent. So if I want the cotangent, that is the reciprocal of the tangent. My tangent value that I had on my chart was, on my unit circle was negative 1, and the reciprocal of that is negative 1. Okay? Secant of 3 pi. Okay, I'm going to go back to my unit circle because that's one last thing I like to add to my circle. Okay? 0 pi, 1 pi, 2 pi, 3 pi. So this is where 3 pi is. 4 pi, 5 pi, 6 pi. So if you keep going, I'm hoping you're seeing that pattern. Okay, and that pattern we have is that all of your, okay, that's not the letter E. All of your even pi's are over here, and all of your odd pi's are over there. So again, I'm just trying to get us cut down on the work somewhat. Okay, so secant of 3 pi, odd pi's are over on the left, and those coordinates are negative 1, 0. Secant is 1 over the cosine. Cosine is the x value, so 1 over negative 1 is negative 1. Okay, now next, what is the decimal value of each expression? Use the radian mode on your calculator. Round your answers to the nearest thousandth. Okay, so when I do these problems, I am going to tell you how to do it on Scientific, and I'm going to show you how to do it on the Inspire calculator also, because that's what we use so much. So, first off, make sure your calculator's in radian mode. So if you don't know how to do that, you need to see me, because it, of course, depends on what kind of calculator you have. But on a Scientific calculator, okay, to put in the cotangent of 13, you've got to know that this is the reciprocal of the tangent function. So in your calculator, you would put the tangent of 13, make sure that that whole thing is in parentheses, and your calculator might automatically open that up, so you would close it, okay? And then you find the reciprocal button or raise it to the negative 1 power. And when you do that, then you will um, get the actual answer for the cotangent of 13, which is, we're going to go do it on the Inspire so you can see if you've got that right. So let me pull that up right here. Now, on an Inspire calculator, you have a couple of options, but you have the trig button, which I'll see if that'll let me do that, or I have to. Good. All right, and so you've got all of your functions, so you don't have to worry about those reciprocal issues. Cotangent of 13, and you have a button down here which is pi, and so you can put in whether you want degrees or whether you want radians, and then you will be sure to get the right answer. So if I round this to the nearest hundredth, that's going to be 160. Excuse me. So this problem will be negative 2.160. You don't have to write that zero. That's rounded to the nearest thousand. So let me pause and we'll go get the rest of the numbers and you can check yourself. Okay, so here are your answers. I hope those checked out. And if they didn't, please be sure to come see me. Okay, we're going to go on to our graphs. So I am going to, when we've talked about these graphs up at the top of our page, we have y equals sine, cosine, and tangent. They were all in different notes, okay? And since we're talking about the reciprocals, we actually want them in the same place. So I'm going to go review those really quickly and put them on here. Y equals a sine of theta. Remember, our period is 2 pi. So I go out 4 tick marks to 2 pi. And actually, I wasn't supposed to put those zeros yet. I just want to label it. My bad. 2 pi. I was getting ahead of myself. Pi. Parent function negative 1 to 1. So we label our axes, and then we remember that the sine function starts at a 0. So I start at a 0. I end at a 0. Halfway between is a 0. Halfway between the first two is a max. And halfway between the last two is a min. And since it's just a reference, I'm only graphing one, I don't like that. I'm only going to graph one period, and I'm not worried about the arrows or anything like that. I'm just trying to remind you what those key points are. Okay? All right, let's look at our cosine function. Our cosine also has a period of 2 pi. So I'm going to go out, 4 tick marks, label it pi. Second one, label it 4 tick marks, 2 pi, halfway, pi, up to 1, down to negative 1. And remember that my cosine starts at a max up here at 1, ends at a max. Halfway between is a min, and halfway between those 2 points are zeros. And so that gives me this of what it looks like between one period. Okay, then we have our tangent function. Okay, and our tangent function was different in that its period was pi. And what we did when we graphed it, we actually went out at that 2 tick marks and labeled it pi, but then we remembered or learned why there are asymptotes halfway between. So I have an asymptote, and that's what reminds us that it straddles, the tangent graph is going to straddle my y-axis. This is pi over 2, and this, of course, is negative pi over 2. And halfway between my asymptotes, I have a 0. And then halfway between 0 and pi over 2 is pi over 4, and I know the tangent of pi over 4 is 1. But if I go halfway, because all of these are all about start, stop, halfway, and then halfway again. So I'm starting in an asymptote, ending in an asymptote, halfway is a 0, and then I go halfway to the right is up, so halfway to the left is down. And that's where we get our key points to make this shape. Okay, now I don't necessarily flip this the way I flip these, so I'm actually going to go on down to the cotangent and talk about it. It is the reciprocal of it. So that being said, the period is going to be pi again, and I'm going to go out to the second tick mark and label it pi. But remember, okay, if on the tangent, you should know because that's going to be an asymptote, and then that next tick mark is going to be a 0. So if it's 0 for the tangent, then that means the cotangent at that point is undefined, and so that's where my asymptote is going to be now. So me go put that on there. Oh, one of those disappeared on me. So that means that my asymptote is now at pi, and I have another one at 0. And then I will continue between, halfway between my asymptotes is a 0. And up here, I went halfway to the right, which was that point of pi over 4, 1. And the reciprocal of 1 is 1. So where is pi over 4 on this graph? It's right here, which is why we are this time going to the left and going up 1, and to the right and going down. So this makes my cotangent graph look like this. Okay, so my dots, make them bigger so it contains, anyway, y'all got the idea. Okay, so my tangent graph is kind of rising and my cotangent graph is falling. Cotangent, the asymptote is at the end of that period, and the tangent, we think of it as halfway, and it straddles the y-axis. Okay, so let's go back to the reciprocal of this. The reciprocal of the sine is the cosecant. It will have the same period, so I will be labeling it the same way. 2 pi, pi, up 1, down 1. So I'm labeled, and I'm going to put the exact same key points on here. So if it's 1 over the sine, then I start at a 0 because my sine knows. I'm putting the key points that I use for my sine graph. Starts at a 0, it ends at a 0, halfway is a 0, halfway between the first two is a max, halfway between the last two is a min. Now, the difference is it's 1 over these values, and 1 over 0 we've just talked about is undefined. So what am I going to have at these points now? I'm going to have asymptotes wherever I have zeros. So, oops, that guy went crooked on me because I got a little excited maybe. Okay, so my zeros, everywhere I have a 0, I'm going to put an asymptote. Now, the reciprocal of 1 is 1, so both points, this point is on both graphs. But if you think about, if I went halfway, the reciprocal, so when I'm graphing it and I'm halfway, the reciprocal is going to be 2. Or if I'm down here at 1/10, the reciprocal is 10. So I'm telling you that so hopefully you can realize and understand why these are basically parabolas that are going away from my midline, because I'm taking the reciprocal of all of these values. And when I take the reciprocal of them, it looks like that. Okay, so secant, 1 over the cosine. Again, the same period. Okay, I'm going to have my 1. I'm going to have my -1, except for I missed that tick mark. I'm going to have my -1. I'm going to go out 4 tick marks and label it my period. And my key points here, I start at 0 max, end at a max. Halfway between is my min of -1. And halfway between the two max and mins are zeros. Now, because it ends up straddling, if you can tell, I'm going to put another one right here. And so my asymptotes will be, of course it's gone, again where my zeros are. So I'm going to have an asymptote there. I'll erase that. An asymptote here and an asymptote here. And I go to my 1s and I'm going to make them parabolas going away from my midline. Yeah. And there we go. So let's go. We're going to graph 4 examples and then we'll be done. So the first one, I have the cosecant of theta minus pi over 2. So what I'm doing on this graph, cosecant of theta minus pi over 2. The first thing I'm going to do is go find out what my parent function, my reciprocal, okay? Cosecant is 1 over the sine, okay? And then this -2, we know that that's going to move our graph, shift our graph down 2 units. So my period is still 2 pi. So I'm going to come here, excuse me, and go out 4 tick marks, label it 2 pi. And the second tick mark will be pi. Since I'm going down by 2 units here, I'm going to go ahead and label my graph by 2's. So that's -2, and that's -4. Okay, and as we have been doing, I'm going to go ahead and graph that midline. So my midline is now not at 0, but at y equals -2. So now I have both axes labeled, and I'm going to go make my key points of the sine function. So my sine starts at that midline. This is my new midline and my new zeros. All right, but that's where my zeros will be, on that midline. So I start at a 0, end at a 0, halfway between is a 0, halfway between the first two is a max. We go up 1. Remember, my scale's by 2, so I'm only right here. And then if I go down, it's there. and then where my zeros are, okay, we're going to put in asymptotes because we're dealing with a reciprocal function. So I have an asymptote here, and an asymptote here, and an asymptote here. And those lines all need to be dotted. It's just something helping us to do our graphs. So I come through, try not to go below that point, and draw my parabola up and my parabola down and approach your asymptotes. Okay? All right, look at 44. 44, I'm going to secant of 1/4 theta. That is 1 over the cosine. My period is normally 2 pi over 1/4. So that's 2 pi times 4 over 1. Keep change flip, which means it's 8 pi. So I'm going to go 1, 2, 3, 4 and label it my period of 8 pi. Halfway is 4 pi. And I didn't shift up or down, so I'm going to leave this at 1 and -1. And so this is my midline stays the same. So now I'm ready to go put my points on secant of theta, which is 1 over the cosine, and the cosine starts at a max. So I'm starting at a max, ending at a max. Halfway between is a min. Halfway between those points are my zeros. And again, I carry it back 1 because this one's going to end up straddling. So let's go put in our asymptotes, which is wherever I have zeros. So here's an asymptote. Here's an asymptote. Here's an asymptote. And then I graph my parabolas. So I'm graphing away from my midline, always away from my midline. So if it's not a reciprocal, you go towards your midline. If it is a reciprocal, then you're going away from your midline. That was pretty bad. One of the things I want to point out, it says from 0 to 2 pi. So really all you had to graph was this piece right here. But I think it just helps to understand when you have to continue that graph. Okay? All right. Let's go with number 45, and I'll put the little work that we do right here. So 45, I should have done that. My bad. This is graph for 43. This was to try to get it all on one paper. This is the graph for 44. And 45 is here, and we're actually going to put the graph right here. Okay, so 45, y equals a negative secant. Again, it's the reciprocal of the cosine. And my period is 2 pi over b, which is pi. And so that's going to be 2. So normally we go out to the 4th tick mark and then label it 2. But because I'm supposed to go between 0 and 2 pi, I'm actually going to do every other one. So I'm going to not go by, anyway, I think y'all got the idea here. I'm trying to make sure I get 0 to 2 pi on the axes that I have. And we can handle it this way. So I can still think of it as 4 tick marks and halfway between. So those are my tick marks. I'm not going up and down. So this is going to be, I'm not shifting up or down. So I've got my 1 and -1. I'm doing 1 over the cosine. So it normally starts at a max, but I do have this minus sign here. So I'm going to start at my -1. And the end of my period, which is 4 tick marks, but we have it here because we know we can do halfway. So it starts at a min, ends at a min, halfway between is that max, and halfway between those are my zeros. And so we got to continue because 6.28 is over here, so I go another, those are like my 4 tick marks, halfway between is a min, and halfway between are my zeros. Again, another period of 2, halfway is my max, and halfway between those two are my mins. And if I continue that pattern, okay, it would go like that. Okay, so it's also real important to be able to put sorry, be able to continue the pattern. Okay, so let's go here. So wherever I have zeros, I'm going to put asymptotes. So I have an asymptote, lots of asymptotes. And I know for years I did this without a tool, so I do know how nice it is to have a tool. So now I'm going to go graph my function, and wherever I probably would have helped to extend my asymptotes so I could have something to draw to. So we're doing this. And drawing my parabolas away from my midline again. Okay? Alright, I'll finish that up. Look at 46. 46 says y equals the cotangent of theta over 3. Okay? So, moving down here. I'll go right here. Right. So cotangent is one of those graphs that I really don't want to, I don't flip it like I do the other ones. I don't do the same key points. I'm actually going to remember this one because my period is normally pi, and that's actually where my asymptote is. And so I know that halfway, this is the other asymptote, and halfway to the left is my 1. So I'm just getting my reference graph before I actually go and put it on there. Okay, so my period of my tangent function is normally pi, but this in front of that, remember theta over 3 is the same thing as 1/3 theta. And so that's going to be pi times 3 over 1. So my period is 3 pi. So for my tangent, I'm going to go out 2 tick marks, and I'm going to label that pi over 3. And that's where I know that I have a tick mark. I mean, excuse me, that's where I know I have an asymptote. So I'm going to put my asymptote here, and that means it's also at 0. That's the beginning. And then halfway, I have a 0, and halfway to the left, I have a 1. I go up, and halfway to the right, I go down. And so this is my tangent of cotangent of theta over 3. And keep in mind, between 0 and 2 pi, you know what? I'm so sorry. Y'all, that's really bad looking. Let me fix this. I don't know what I was thinking. So I hope you're not yelling at me at this point. But um, that asymptote, I'm going to draw that asymptote again. I'm so sorry. And that was not supposed to be pi over 3. That was supposed to be 3 pi. So I'm glad that I mentioned what I was fixing to mention. This is 3 pi, okay? If I go between 0 and 2 pi, then of course you know that that's 2/3 of the way. So it really would cut off right here. If you looked in the back of the book, or you had the answers available to you, you would only see that much of the graph. So I hope that made it easy for you to graph reciprocal functions. If you have any questions, please come see me.